All right, today we are going to talk importing, exporting, web scraping, okay? Getting data into R and stuff like that. Some good stuff. Okay, so let's just talk about importing data, importing and exporting data. All right. Basic commands, there's read line, okay? I don't know if you guys ever used read line. Read line is a way for you to get input from what we call the standard in. So your console, when you type stuff into the console, that's the standard in, and read line will prompt the user for that. So if you wanted to play a game where you ask the user what move they want to do, you can use read line, okay? For Chutes and Ladders, it barely counts as a game because there's no decision making for Chutes and Ladders. It's just once you decide to play Chutes and Ladders, whether you win or lose is determined entirely by the spinner or the die that you roll. You don't make a single decision in the game. You just roll the die, spin the spinner, move, do what the chute or ladder says to do, and then your game there's no strategy there, okay? Which makes it perfect for a kid's game, right? You don't want to burden the kid with thinking. Okay. Read.table, read.csv. I think you guys are familiar with these commands as far as reading in text files and stuff like that, okay? One thing to note is if you've got text information, strings as factors equals false is probably a good setting, unless you've got actual categorical information, right? Factors are for categorical data, so we use factors for that, okay? There's a few really great packages in the tidyverse, okay? The tidyverse is a set of packages developed by Hadley Wickham and kind of the RStudio team and other people, but they're really, really great, okay? And one of them is called Reader, okay? Readr is basically replaces your read.csv file with read_csv, and it just gives you better performance, creates tables and stuff, and it's pretty good, okay? You got Excel files, you can use read Excel. You've got other software programs, SAS, SPSS, and Stata. You can use Haven to import those, okay? I know in the stats department we kind of turn our noses at Excel, but I love Excel, okay? I think Excel is great. It's still worth putting on your resume if you're really good at it, right? You can do quite a bit with Excel very quickly, but for statistical analysis, R is more powerful and stuff. I don't know if you guys ever encounter SAS, SPSS, or Stata. Not really. I think the social sciences, some of them still use SPSS. SPSS is a great program, okay? It's a really good program. Point and click interface. You can do quite a bit of statistical analysis, but you got to pay money for it. It's not as extendable as R, and so us in the stats department, we all use R. Stata, we used to use Stata in the stats department, but not so much anymore. And SAS, a lot of businesses still use that. I have not touched SAS, so I couldn't tell you a single thing about it, okay? And then there's another package called data.table. That's technically not part of the tidyverse, but it can import some very large things there. Okay, you can watch this webinar if you're ever going to deal with any of the other stuff. So Reader, probably the CSV seems to be the de facto data delivery system these days, okay? And so you can use read_CSV, okay? So the Reader basically just replaces the dot with an underscore, and it gives you higher performance. But if you've got tab separated or other fixed width files and stuff like that, these are things you can do, okay? There's a data.table has a function called fread, all right, which acts very much like read CSV, but it's a little bit it's different, and it's designed for fastest performance, okay? So I would say just use read underscore CSV most of the time. It probably fulfills most of your import data needs. But if you are faced with a data file, like a CSV file that's over 1 gigabyte, okay? So if you do something like for DataFest, you might have a data file that's over a gigabyte big. fread is going to give you the fastest performance there, okay? Don't do read.csv. The base package, the base read.csv is going to just choke on something that's like a gigabyte big. Okay, fread will do it. Read underscore CSV can handle it, but it'll take longer, okay? Read underscore CSV is probably good for anything from a few kilobytes to a couple hundred megabytes, okay? But once you start getting into the big data territory, fread might be better. Okay, this is just straight from the reader website. Okay, basically says fread is faster. Okay, but different purposes in mind, I guess. Okay, read Excel is for Excel packages or Excel files. Okay, so an Excel file, they're called workbooks, and you can have multiple sheets of spreadsheets in there, right? And so if you want to, by default, if you just use read underscore Excel on some data set, it's going to import the first worksheet. If you've got more than one worksheet in there, you can specify which worksheet you want by either name or number. Okay. Sometimes you want to download a file. Okay, so oftentimes out there on the internet, people have data files posted, okay, like on Kaggle or on GitHub or wherever it might be, and you just want to download it, okay? Or you want to create a script for someone to use, and you can just give, so like let's say the file is like a couple hundred megabytes or something like that, okay? You don't want to have to email the entire file over, right? You can just email the script, which has the instructions to download the file. And so you can use download.file. But the download.file is a function that comes in base R, and it was good in the old days of the internet, okay? Today, everywhere you go, pretty much every website is secure now, okay? Every website has a lock icon, and if the website does not have a lock icon, almost all browsers will now alert you and say not secure, not secure. Meaning if, I don't know, someone hijacked your Wi-Fi spot, they might be able to see what the website is sending you, okay? Pretty much every website now uses a secure HTTPS, which makes it secure so that even though someone hijacks your Wi-Fi, they won't be able to see what you're receiving, okay? You don't need a VPN. I know some VPNs will talk about like, you should buy the VPN so you can get a secure thing, and as long as you're on a HTTPS, people aren't going to be able to do this kind of attack. But anyway, so download.file struggles with these secure connections. So library downloader fixes that. Okay, and so if you ever need to download stuff off the internet, use library downloader. And here's just some sample code. Saving and exporting your data. Okay. As you build up objects in your workspace, your global environment, you can save those objects to a file. Okay. And you just list off the objects that you want. You just say save object 1, object 2, object 3, or whatever. And then you say file equals this name, and it's going to save all of that data into a native r.r data file. Okay, and then you can send that to someone else, and if they use R, they can open it up. Okay, but if you want to send your data, like a data frame, to someone who's not using R, then you'll have to save it in a different form. Okay, so if you've got a atomic vector, you can use the command write. Write will create export basically a plain text file of an atomic vector, and this includes matrices. It just treats the matrix as an atomic vector, and you can specify, number of columns, but generally we'll just say number of columns is 1, and it just straight down, all the elements in the atomic vector go down. Okay. If you got a data frame, you can create a CSV file using write.csv. Okay. And by default, R includes row names, and so you might want to say row names equals false, so it doesn't do that. Okay. And that's to kind of export any of your data objects. Is that good? All right, there is a package called Lubridate, okay? Part of the tidyverse. Play on the word lubricate, which just kind of makes things smoother. Lubridate makes dealing with date and time information much easier, okay? So I just want to show you, without Lubridate, these are kind of the issues that you might run into, right? So you might have a date stored as this string here, okay? January 15th, 1999. And to convert it into a date, you have to say, okay, I've got something where the date is written out, or the month is written out, the date is like this, and the year is this, okay? And you have to include the comma, and then it will understand, okay? But if you forget the comma, R says, I have no idea what you're talking about, okay? It doesn't fit the format. I can't make a date out of this, okay? Same thing here. We've got 12/15/2001, so December 15th, 2001. Then you say month dash day dash year, and it says, okay, I understand this is a date, okay? But if you leave out the dashes, R says, I have no idea what you're talking about. I can't do this, okay? Question. Is date information a categorical variable or numeric variable? All right, so what's the criteria for whether something is numeric or not? Yeah. There's a hierarchy. You can make a comparison, right? You can say something like, this person is 120 pounds, this person's 130 pounds, this person weighs 10 pounds more than this person. That makes sense, right? Can you do that with date information? This person born January 12th, 2000. This person born January 18th, 2000. This person is 6 days older than the other person. Does it make sense to do that? It does, okay? And because of that, I argue that date information is numeric, okay? But how can date information, why, it doesn't look like a number, right? So what the problem is we're all accustomed to our numbers being base 10, okay? So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you go, now you have the tens place and then the hundreds place. We're accustomed to all of our numbers being written in base 10, okay? But if you think about what a date represents, so January 15th, 1999, that is just a really weird base system for writing out how many days have passed since an arbitrary point in time, okay? So the Western world has kind of said, January 1, year 1 AD or CE is kind of our base point in time, based on, religious reasons. And we have this weird system where we say, okay, every 365 days, that's a year, but every fourth year, it's 366 days, but not every 400th year. And then, these months have 31 days, these months have 30 days, and, we decided to call them January, February, and all the way up through December. But then, Julius Caesar wanted to have his own month, and so did Augustus Caesar. And so even though December starts with the DEC and should be the 10th, and now the 12th thing. And just it's a weird thing, but we've all the whole world has said, all right, this is how it works, okay? And, but really, it's just this many thousands of days have passed since this arbitrary point in time, okay? And that's actually how the dates are stored in the computer. I think the date is January 1, 1970, and if you look at the date information, it's going to be stored as kind of an integer of how many days have passed since this arbitrary point in time. And that's why it makes sense to say this person is born 64 days after this other person, okay? And you can say that. Yeah?
If you did a date before 1970, would it be a negative?
It would be a negative integer, yeah. Man, I haven't, let me just see. Okay. As dot date. Okay, so let's do 01 dash, I gotta do this. 01 dash 01 dash 1970. I think I'm gonna have to do the format %d dash %m dash %year. Is that right? Okay, so that works. Oh wait, no. Okay, and then if I do as numeric, okay, so that's day 1, all right? And then so if I do 1971, this will be 365. 1972 is 730. 1973 is 1096 because that was a leap year and stuff like that. Okay, and then if we go back in time to 1969, it's negative 365. Okay, so this is just how we store date information in the computer. Okay, so it's numeric. It's numeric. Okay, but anyway. All to say, dates are written weird, okay? We have this weird, it's kind of a weird base system. It's like a base 365, kind of 366 every now and then system. And anyway, so if you have stuff in this string form, and so let's say you have a form, it's like enter your birthday, okay? And people write their birthdays and all of these weird things. Your regular as.date conversion is not gonna work. Okay, so if we say this one has commas, it works for the first one, but it doesn't work for the other two. We say this one has the format as dashes, it works for the second one, but not for the other one. We say this one has slashes, and it works for this one, but not for the others. Okay, Lubridate makes this way easier. Okay, I've got string dates, different formats here, and I just say all of them are month, day, year, and it does them all. Okay. Can you imagine trying to have to like deal with every single kind of format here? It would be heartbreaking. Okay, this is your job. Welcome to your new job as a data analyst, and that might be your first assignment, right? Cleaning up your text data from some poorly designed web form that you'd had no input over how it should be designed. And you have to clean up all that input. It's terrible, right? So anyway, this stuff like this makes your life way better, okay? So use Lubridate, okay? One thing that is, if you have a date like this, 03, 04, 05, it's super ambiguous, right? Is this March 4th, 2005? That might be how most Americans see it. If you ask a European, they're gonna say it's April 3rd, 2005. If you ask a person in the Army, they might say it's 2003. April 5th or something, I don't know, okay? So you kind of have to specify what order these things appear in, okay? All right. Okay, now let's talk RVest and web scraping, okay? RVest, play on the words harvest, and we use this thing called Selector Gadget, okay? The way it works is websites are written in HTML, hypertext markup language, and it uses these tags, and it says like this thing's a link, there's a tag for a link, there's a tag that says this is a headline, there's a tag that says this is a bullet point, okay? And then we also have CSS, which adds additional kind of, you can specify classes and say, this text should look this way and this text should look this way, and everything's kind of given all of these tags. And so here I want to kind of Reddit, and all of these, every single link that appears on Reddit will have these buttons that say, this many comments, share, save, hide, report, stuff like that. And they're all formatted the same. And the way the formatting is controlled is via the HTML tags that underlie the website. So let me go to old.reddit.com, okay? And so this is kind of the front page of Reddit, and I'm going to, and if you click View Page Source, it's just a mess of text, okay? This is what it looks like. Your web browser looks at this stuff and says, oh, this is what it should look like, okay? And basically, all of these things are held consistent using tags. And so this is like a simplified version, but you're going to have these tags and these kind of these, greater than, less than sign things. And this is like the text that appears here, 4,612 comments, gets this tag that says classes comments and stuff like that. This thing that says share gets a tag that says the classes share button and stuff like that. And what the Selector Gadget does is it identifies all the elements on the web page with kind of the same type of tag, okay? So you go to the Selector Gadget, you click that link, and it activates this little bit of JavaScript, and you're going to kind of click one of the buttons here, okay? And it highlights all this stuff. So what you're going to do is you're going to kind of say, I don't want this, and it selects, and it says, okay, the way you're going to select all of these things that now appear in yellow is by using this tag that says comments, okay? Let me just kind of show. And if I do like save dash button, okay, and I think, and I select everything with the save button tag, it selects everything in yellow, gets highlighted as all the save buttons and stuff like that, okay? And I can clear all of that out. Okay, and so here I'm going to just use the .comments tag, and with Arvest, this is how I'm going to extract all of the kind of the text information on the website that's been identified with that comments tag. Okay, so I say we give it the command read HTML, and we just give it some website address. Okay, so in our case, the website address is old.reddit.com, and it's going to read in this page to old Reddit. Okay, and then from old Reddit, we're going to say from there select all the nodes or the all the items on that web page where the tag is .comments. Okay, with the .comments tag, and when we do that, we can say from there extract the text that has been highlighted, the HTML text that has been tagged with .comments. Okay, if you're familiar with how a web page is made, the tags themselves can also have other attributes, right? You can have attributes like this thing and this thing and this thing, and so there's other options to select certain attributes from a tag. But most often we're just going to go for kind of the HTML, the text there. Okay, and so this is on the web page. Okay, there's lots of text on the web page, but as far as the text that has been identified with the comments tag are these ones that say 7 comments, 6,951 comments, 1,180 comments, so on and so forth. Okay, so we're able to go on a website which has a lot of stuff and just pull out certain elements of it. Okay, and then from there, now that I've got this text information or this string information or character, I can apply regular expressions, and we'll learn regular expressions in like next week. Okay, but just a simple one is just I want to pull out the things that look like digits. Okay, so we're going to say //d, and that's anything that has a digit plus is one or more of those things. Okay, and so it goes from 7, 6951 to 1180 from the character into numbers. So we say string extract anything that looks like a digit, turn them into numbers, and now I have a numeric vector, and I can ask for the mean, I can ask for the median, I can do statistic stuff now that I've got a numeric vector, right? And so Arvest allows us to kind of go to web pages and pull out these elements and stuff by using the CSS tags, right? Does that kind of make sense what's happening? Okay, so again, underneath the web page is all of this stuff, and it's very difficult to parse, but if you look at it, okay, there's like a little thing here. This is a little tag that says class equals live timestamp or something like that, right? And it says this post was made 4 hours ago, etc. Okay, and we use those tags to identify the different elements on the web page. Okay, Rvest does not work well on certain modern websites that are generated using JavaScript. Okay, so for example, a lot of websites these days, not a lot, but some websites feature infinite scroll. Okay, so if you go on Facebook, you just keep scrolling and scrolling and scrolling and scrolling, and you can scroll for hours. Okay, you go on Instagram, you can just keep scrolling and scrolling and scrolling. Okay, and then the new Reddit, actually, so if you just go to reddit.com, it also features infinite scroll. Okay, and so you can just keep scrolling and scrolling, and as soon as you reach the bottom, the web page goes, oh, I reached the bottom, server, give me more stuff to show. Okay, and it just keeps going. It just keeps going and going, and you can spend hours, right? And that's different, okay? And Rvest will struggle with websites like that. It might be able to pull some information out, but it's going to struggle because it's expecting kind of a thing with kind of a defined start and finish, okay? And so this one, it only shows 25 links, and if you want to see more, you've got to click next, right? Whereas the infinite scroll, you just kind of keep scrolling, right? And a lot of websites now do infinite scroll because they find it keeps people on the website longer, right? Every time you have to click next to go to the next page, you might rethink your decision to click the button, right? Your brain has to say, oh, I've got to take an action. Maybe I should click X and exit out the browser instead. But if you're just scrolling, it's very easy to just keep going, right? And kind of the hyper opposite is like, there might be like, there's those clickbait articles, right? It's like 13 places you could never imagine, blah, blah, blah. But it's like every single one of those things is like, you've got to click next to just see the next item. And like, who gets to the end of the list? Nobody does, right? You click a couple of these things and you're frustrated that you have to keep clicking next. And so you stop halfway reading through the article, right? And they do that because every click generates a new advertisement, and they can they don't care about you staying on the website. They just want to get like 5 clicks out of you to get their ad revenue, right? But sites like Reddit and Facebook, they just want you to stay on there forever. So they minimize the clicks by giving you infinite scroll and then putting in ads every, 10 posts or something like that, okay? All sorts of stuff just to manipulate you. But anyway, so if you have a website where it's kind of generated via JavaScript, okay, oftentimes the CSS tags are incomprehensible, okay? So the other tags back here was like, the tag was comments, and that kind of made sense. Like everything that had the comments tag was labeled with a comments class, but now the class has this incomprehensible thing, and this thing is likely to change in a couple of, in a few hours or a couple days, and these tags, probably won't work in the future, okay? Because these are kind of generated automatically via some JavaScript code to do stuff. So anyway, I ran this a couple hours ago, and so this happened to be the front page of Reddit at that time, okay? And so it pulled some stuff. It pulled 7 items here, but then I guess that was it for the web page. Whereas if I go to the old website, it loads up all 25. It's got the page has a defined start and finish, and so this actually pulls up. You don't see the items 11 through 25, but it pulls up 25 things. Okay, and then the node that we select using the CSS gadget or Selector Gadget is .title.mayblank, which is a little bit more comprehensible as a human, right? Versus this gibberish here. Okay, and so this is Rvest works better for these types of things. Okay, if you do have a website that is generated with JavaScript, and you really want to scrape that stuff or something like that. There's another program you can use called Selenium. There's a package that interfaces with R and Selenium, and that's R Selenium. It's got a bit of a steeper learning curve. I actually haven't really used it myself, so I'm not able to guide you right now. Okay, and if you're thinking of doing a major web scraping project where you're going to kind of like crawl out to a whole bunch of different pages and keep following links down some tunnel, then I would recommend something using Python. And there's different things. So Beautiful Soup is the simplest and easiest one, and that's mostly for short jobs. Scrapey is popular, and then Python also has a Selenium interface. Okay, Selenium basically sets up a browser, and you give it instructions for like click this link and follow that link and stuff like that. Okay, Arvest has some basic browsing capabilities, which I'll demonstrate to you. All right. Is this okay? All right, so for the rest of our time, I'm going to do an Arvest demo. I'm going to demonstrate Arvest, and I'll post up all of this code after class and all of that. Let me just restart my R session. Clear. My environment is clear. Those in the back, can you guys read the text? I've tried to blow up my text to, I think, 150% or something. Is that visible? Okay, so I'm going to start just by loading up Arvest, okay? And I'm also going to load up library stringer, and this gives me regular expression abilities, and again, I'll teach you guys regular expressions in next week, okay? It's really great stuff that it's technically not R, but it's the best. Okay, all right, so this is what we're going to do. We're going to go to this web page, okay, which I think I've already loaded up. This is the IMDb page for the Lego Movie. It's a great movie, okay? I've got the Lego Movie, Lego Movie 2, the Lego Batman movie. Okay, so anyway, so this is the Lego Movie webpage, and we're going to get it into a form that Arvest can handle by using read_HTML. So you just use read_HTML, you give it the web address, and it reads it, and here it's going to store it as an object, and it says Lego Movie is a list of 2, okay? And then what we do is we're going to select nodes using the Selector Gadget, okay? So the way this works, okay, is I'm going to click the Selector Gadget. So what you're going to have to do is you're going to have to go to Selector Gadget, okay, search Selector Gadget, and then watch this video on how it works, okay? And you're going to just click and drag this link to your bookmarks bar, okay? And this is just a tiny bit of JavaScript code, and anyway, so what I do, this is in my bookmarks bar, I click Selector Gadget, okay, and it loads up this little thing in the corner here, okay, and then I hover over the piece of text that I want. So I want to pull out this number 7.8. This is the IMDb rating for the movie, okay, so I guess 312,000 people voted on the Lego Movie, on a scale of 1 to 10. And the average is 7.8, which is pretty good, okay? So I click that, okay? And when I click that, Selector Gadget highlights a whole bunch of stuff in yellow, okay? And I'm going to say, well, I don't want that. I just want this number 7.8, okay? So what I'll do is I'll just click one of the yellow things that I don't want. So in this case, I don't want the year 2014, so I click that, and there's a red box saying, okay, I'm not going to get that, okay? And so it changes here. Wait, let me just kind of show you again. So I come to 7.8, and if I click that, it selects a whole bunch of stuff in yellow. It basically says it's going to select everything with a span tag, and there's 592 elements. Okay, that's way too many things. So I'm just going to click one of these things like this, and it says, okay, now we're only going to select those things with .ratingValueSpan. Okay, and it says there's going to be 3 things. Okay, and if I look carefully on the web page, this element that says 7.8 out of 10 shows up in tiny tiny elements, I'm gonna just click that and say I don't want that either. Okay, and when I do that, only 7.8 is highlighted in green, and there's only one element. Okay, and it says okay, the tags you use to select this is strong span. Okay, so I'm gonna highlight that, Control C to copy it, and now I'm gonna select the tags with strong span. So I go back to R, and I'm gonna take, so currently in memory I've got Lego_movie, and I'm gonna pipe that into the function HTML nodes. And which HTML nodes am I gonna select? I'm gonna select the ones that say strong span, okay? And this will select the nodes. From there, I'm gonna say I wanna extract out the text. Again, when it selects a node, it selects a whole bunch of stuff, okay? Include the entire tag, because sometimes the tags have attributes in them and you're interested in the attributes. But in this case, I just want the text that's been tagged. Okay, so I'm gonna just say I want the text, okay? And if I stop here, this will return 7.8, but it's gonna be a character value, okay? And so if I wanna do something like put it into calculate the mean, or add values together, I've got to make it numeric. So I'm going to do Lego movie, HTML nodes, HTML text as numeric, and I'm going to save it back into rating. Okay? And so rating is now this numeric value of 7.8. All right? Is that good? Okay. All right. So one of the best things about IMDb, okay, is that you can go to a web page, right, a movie, and you can see who are the actors, who is it, the cast, right? Who was in this movie. So in this case, we've got Will Arnett, Elizabeth Banks, Craig Berry. Here, I'm going to just zoom in a tiny bit. Okay, and so let's say I want to select the cast. I'm going to click Selector Gadget again, and come here. I'm going to say, okay, I want to pull out this element, Will Arnett. So I'm going to click that. Okay, and again, it highlights a whole bunch of text in yellow. It highlights everything with an A tag, okay, an anchor tag, and there's 574 elements. Again, that's too many things. So I don't want all of these other things. I just want Will Arnett, okay, and Elizabeth Banks and Craig Berry and those things. So I'm going to just click something that I don't want, which shows up in red, and it unselects a bunch of stuff, okay? And just by doing that, now it has reduced elements to 15, and I can scroll up and down the web page, and there's nothing else highlighted in yellow. So this looks to be the correct set of tags to use. So I'm going to go ahead and copy that, and I'm going to come back to R, okay? And I guess last time I did it, these were the tags that got selected: TD, nth child, 2A, okay? And so here I'm going to do Lego movie, HTML nodes, HTML text, okay? And what we see is that there's 15 elements selected here. And so when I run this, cast becomes a vector of length 15. There's 15 elements in my vector, okay? And what I notice is that the elements that I've pulled have a space in front of the text and also end with /n, which is a new line character, okay? So it's a little bit too much stuff, and so one of the things you can use is you could say trim off the white space, trim off any spaces in the front, any space or white space in the end, okay? So I'm going to take cast, I'm going to run it through string trim, okay? And there we go. Now I've got the names of the actors in the movie. We got Will Arnett, Elizabeth Banks, Craig Berry, Alison Brie, and they show up here. And so we are able to pull out elements from the web page based on kind of the tags that show up, okay? And you can do this for any of the other stuff, right? So one of the things on the web page is some user reviews, right? The Lego movie, a surprising accomplishment. I went into the Lego movie expecting drivel. I thought it'd be like the DC ones, but without the DC elements to appease me. Thankfully, I was wrong, way wrong. This hugely acclaimed, multi-award-winning, Oscar-nominated, feature-length animated Lego movie is an entertaining roller coaster ride for all ages. Okay, agree. All right, so I can just using the same kind of strategy of figuring out which tags to use, I can pull out the text of that, right? So here we could do a review, and it's got all of this. I guess when I loaded the web page, it changed somehow. Okay, so I'm not sure how Okay, so yeah, the web page feeds a slightly different web review. Okay, so 8-star. Never have I been so wrong about a movie. Okay, wow. Okay, like many of you the first time. Okay, so anyway, we love the Lego Movie. It's great. If you haven't seen it, I don't want to hype it up, but it's pretty good. All right, Lego Movie 2 is also great. Okay, Chris Pratt plays a cartoon version of himself. I found it humorous. Okay, all right, and then again, other things. If you're familiar with HTML, you know that tags have attributes, and so image tags come with a source attribute, and that's going to give you like the URL of where the image is stored. And so, like the poster, there's I can extract this, and this will be the URL of where the poster is stored on the internet. Okay. IMDb is owned by Amazon, so that's why you see it showing up on Amazon's servers. Okay. And so you have that. Okay. Okay. Just bear with me for a little bit. I might go a couple minutes over. Please forgive me. All right. One of the most impressive things is that you can create an automated browser session. Okay. And so what we're going to do is I run this code HTML session. This creates a session. This is basically like a little browser that exists inside of R. And what I'm going to have it do is I'm going to have it start on this web page, the Lego Movie web page, and I'm going to have it click each of these links. Click the link for Will Arnett, click the link for Elizabeth Banks, click the link for Craig Berry, click the link for Alison Brie, for each of the actors that show up in the cast. When it goes to the web page, I'm going to have it come down and extract the movies that Will Arnett has been in, okay? So this includes things like the Lego Batman 2, which I'm super excited about, okay? BoJack Horseman, Riviera, Arrested Development, all high quality stuff, okay? Elizabeth Banks is part of Miss America, Charlie's Angels, you know, Brightburn, Lego Movie 2, stuff like that, Pitch Perfect 3, Craig Berry's and these other things. I don't know much about Craig Berry, but we're gonna pull out all of their different projects. Alison Brie is in like Glow, and we're going to pull out all of these elements, okay? And we're going to do this by creating a browser session, okay? And so let me just show you how it works for one actor, okay? So starting with a session, which I've currently stored as S, we're going to say follow a link, okay? And you can give follow link like a number that says like follow the 10th link on the page, or you can say follow the link with the text Will Arnett, okay? And hopefully there's only one link on the page that has Will Arnett. If there's multiple of these things, it's gonna just follow the first link that says Will Arnett. Fortunately for us, there's only one, okay? So we're gonna follow that, it goes to a page, and then it's gonna read that page as HTML, okay? And so it follows that page, and it's created the Will page. And then from there, using kind of the Selector Gadget, the movie titles are in this tag that says BA, and so here are the kind of the first 10 things. We can also pull out the years that these things take place in, okay? All right, so what I'm gonna do is I'm going to create an empty list here, all right? Just stick with me just one extra minute here, okay? And using the cast names that we have here, right? So cast, we've got the names of all the actors. We're going to just say follow kind of the first 4 of them. And for each of them, I'm just taking the same stuff, replacing Will page with just generic actor page. It's going to follow the link of the actor name. From each actor's page, it's going to pull out the 10 most current movies that they're working on or projects they're working on, kind of the year information. And then we're also going to store that the actor's name, just make a duplicate, and then we're going to just create a data frame out of that. Data frame, name is name, film is movies, years is years, okay? And we run through this, okay? And you're going to see it follows, you know, the first link, okay? Then it follows the next link, and the 4th link, okay? And it stores all of that information into cast movies, okay? So cast movies is now a list of 4 data frames, okay? We've got the Will Arnett data frame, the Elizabeth Banks data frame, and each of them have the name, the film, and the year of those projects, and then I can just combine these things by running through a quick loop. So I'm gonna take Will Arnett's, and for each of them, I'm gonna use rbind to add these other things together. So iterating through the loop, we go through here, And now I've got a big data frame with 40 rows, and it's got 10 from each actor, okay? And so I think this is a really powerful feature that you can use in RVest to kind of have it go to different web pages, scrape that information, okay? So we'll end there. Thanks for sticking with me, and we'll see you guys on Friday. Please have your academic integrity agreement signed and bring that back on Friday.